Hello students, today we're going to do notes on one section that we haven't quite covered yet, and that is called sequences. Now, you could pause the video first and copy this down, and then we can resume once you're done. So I'm going to continue now. The idea is a sequence is a group of numbers that are in a pattern. So for example, 2, 4, 6, 8, 10. Now, sometimes we want to figure out what is this pattern here. So we might say that for this pattern, you keep adding 2. Now, however, there is something called an arithmetic sequence, and this is when you use a formula to describe what your sequence actually is. Now, ideally, we want to set rules. If we're able to set rules, then we can find numbers a lot easier. Let me give you an example. So if I say we look at the previous pattern, 2, 4, 6, 8, 10, you might be able to find the sixth number, the next number, right? It's 12 because you add 2 again. You might be able to find the seventh number. You might even be able to find the 10th number. But what if I asked you, well, what is the 1000th number? Then what? Because sometimes we see patterns in nature or in life that keep going on, or they deal with really big numbers. So by using arithmetic sequences, what we're actually trying to do is we are trying to find a rule where we can easily pair these numbers and then turn it into a formula. So let's try to turn what we have here, the example, and turn it into a formula. So I'm going to write the example again. 2, 4, 6, 8, and 10. These are the numbers in the pattern. Now, the formula we could say is 2 plus 2 plus 2, but again, it's not a pattern and it doesn't really help us with our 1000th number. So the goal here is we want to find out what is the 1000th number in this sequence right here. That's the goal. So then how would we be able to do this? Well, you have to use something that is called the n. So below this, I'm going to write the n. And I'm going to explain what the n is in a bit. But we're actually going to write down what they are for each number. So we want to pretty much pair all these numbers as the first number in the sequence, the second number, third number, fourth, and fifth. So below the 2, I'm going to put 1, because that is the first number in the sequence. Then I'm going to put 2. Then I'm going to put 3, 4, and 5. Now, in arithmetic sequences, what you're going to do is instead of just saying, oh, I'm going to add 2 every time, you want to make a connection or find the relationship between these two numbers, and you want to make sure that that relationship matches these two numbers and that you can continue to use it. So in other words, what can you do to n to find the 2? Right? What can you do to the n to find the 2? So now, let's see. Well, number 1, we could say, okay, what if it's n, which is 1? What if I did a rule that is n plus 1? Okay, so the first number is 1, and 1 plus 1 is 2. That works. But then, when you do n plus 1 here, so the n is 2, and if you do plus 1, then it's going to be 3. So that does not work. Okay, so that pattern will not work. So n plus 1 is not the pattern that you will use. So the question is, what do you have to do to n to get the number in the sequence? You will eventually be able to find out, maybe some of you already discovered it, well, what if I just doubled the number in the sequence? Would that work? Well, let's try it. So let's try a different type of sequence. So let's do 2 times n. So I'm going to put 2n. Now, we have 2, and the first number is 1, so 2 times 1 is 2. The second one is 2 times 2, and you get 4. Oh, now it looks like it's working just fine, right? Let's try the next one here. 2 times n, and we're just going to do one more. 2 times 3 is going to be 6. So then you find that the formula, okay, so the formula for the sequence is actually 2 times whatever n is. Now the n is going to be the number in the sequence, like which number is it? And so you see that your first rule saying like, oh, well, maybe we could add 2. That's actually not quite true. It's going to be n, which is whatever the sequence number is, and you multiply that number by 2. And people have found that by doing this, you can find the 1,000th number. Because now look at what happens here. So if I'm looking for the first number, I put 1. If I'm looking for the second number, I put 2. If I'm looking for the 10th number, you could see that I'll probably put 10. So then if I'm going to put the 1,000th number, or I want to find the 1,000th number, then it's going to be 2 times 1,000, and you're going to get 2,000. So by the time you hit the 1,000th number, that number will be 2,000. Now, thankfully, we don't have to count and add all the way until we get 2,000, right? You could see how that just takes a long time if we wanted to try that. This is an example of an arithmetic sequence. So you must find the formula that works for this activity. Now, keep in mind, sometimes these formulas could use not just like multiply or add, but it could use a combo. It could use adding, subtracting, whatever. But one thing you should note is that it will most likely just use the order of operations that you're familiar with. So it is about finding what number or what formula actually works. So now let's add one more piece to this below, and that would be, what is the n? Okay, so the n, and I'm going to use parentheses, the n, and let's zoom into that, is the term that represents which number you are looking for in the sequence. Oops, sorry about that. Now let's look at some questions that could be asked when we're working on these types. The first one is, so let's make our own try questions here. All right, so let's say that you are looking, or use the formula 3n plus 4 to find the second and 10th, and I'm going to use the word term. The term simply means like the number, right? Like, so the second and the 10th term, which means that for the second one, let's actually write second. I'm going to do 3n plus 4, which then will be 3 times 2, because that's the second number, plus 4, which then equals 6 plus 4, which is 10. Then the 10th number, same thing. 3n plus 4, 3 times 10 plus 4, and you're going to get 34. You see how this process makes the counting so much easier? You're not just counting each number one by one, figuring out what happens to those numbers. Okay, that's one example there. Another example is sometimes you have to find the formula. So find the formula for the sequence that goes, let's say, 2, actually, sorry, not 2. Let's do 7, and then 9, Oh, my bad. No, actually that is correct. Yep. And then 11. All right, see if you could find those formulas, or the formula for that. So let's do this one together if you're not too sure. If you want, you could pause, try to see if you can find it out. If not, then if you can't figure it out, then, or you want to check the answer, you could just click play. So we start off by always pairing it, 1, 2, and 3. And I try, what could I do with the 7? If I try, or from 1 to get to 7. So one of the options is I could add 6. So 1 plus 6 is 7. 2 plus 6 is 8. So that's not going to work. I could try multiplying 1 times 7, but 2 times 7 is 14. So that doesn't work. So maybe there's a combo. So whenever you get like weird numbers that don't quite fit, you might have to do a combo. Let's try, all right. Let's try 1 times 2. So 1 times 2 is going to be 2. And 7, to get to 7, I need to add 5. Okay, so, and then maybe 2 times 2, 4, plus 5 is 9. Oh, there we go. And then 3 times 2 is 6, plus 5 is 11. So there we go. That's our formula. So what did I have to do? I had to do n. I had to multiply n by 2, and I had to add 5. That is an example of my formula right there. And let me put squares around this just so we have the answer. And the last possible question that you would get is you might have to complete, or it's a combo of the first and second one, but find the 5th term. And then, so finding the 5th term of maybe, let's go with 5, 8, 11. All right, so then the trick here is you have to find out what the formula is, and then you have to still plug it in to find the number. So this is a combo of question 2 and then question 1. So I'm going to pair this up with n is equal 1, 2, and 3. I'll find out what the pattern is. Let's say 1 times 2 plus 3. But then 2 times 2 plus 3 is 7, so that's not it. And so then I'll eventually find out maybe it is 1 times 3 plus 2. 2 times 3 plus 2 is 8. 3 times 3 plus 2 is 8. So then you get that 3n, right? 3 times a number plus 2 is the formula. Now I'm going to use this formula to find the 5th term. So 5th, it's going to be 3 times 5 plus 2, which is going to be 15 plus 2, and that is going to be 17. All right, so right after this, I'm going to give you 3 questions to try out. I would like you to give it a shot, and tomorrow we're going to cover these in class. All right, that's it. Here are the questions that I'd like you to solve, and one more thing that I want to just point out, and that is this. Sometimes you will find that the questions will say find the nth term. That's the same thing as asking find the formula. Okay, so if you can write both of these down for your question, that would be great. That way you might see find the nth term. Next time if you see it, it won't throw you off. It just means find the term, find the formula for that term. All right, so that is, that is it.